What if you could build faster, stronger, and more energy efficient homes? I'd like to introduce you to SIP panels, or structural insulated panels. This is a really useful building system because it gives you a higher level of insulation and it's a more efficient building process. The brilliance of the SIP system lies in its simplicity. But before we get into how we're using it on our projects, I'd like to break down for you how exactly it works. A SIP panel consists of basically a foam core center, and that's usually EPS foam. And then on either side of that is OSB, or oriented strand board. And that is the basic makeup of a SIP panel. The EPS provides for you the continuous insulation barrier, and the thickness of this can vary, anywhere from a couple inches to upwards of a foot. And the OSB kind of provides the structural part of that, because EPS foam is kind of weak, but when you sandwich it with 2 layers of OSB on either side, it gives you that sort of structural aspect that can resist wind loading from the side, gravity from the top if it's being used as in a roof application. So that's the basics of the SIP panel itself. Now, what's really nice is when you start to think about like a basic structure where we kind of have SIP panel here, and I'm just going to kind of draw this more diagrammatically. We got SIP panel on the side, and then let's just say we got a SIP panel up on the top. I'm going to make the one on the roof a little thicker because that's kind of typical. You've got this core of EPS foam. You've got this core of EPS foam on the sides. And then your bottom is going to be any kind of could be concrete. Maybe this building's setting on a concrete pad. Maybe it's framed on a conventionally framed floor. But anyway, you can kind of see that in this composition, if you're a person standing in here, that you've got this nice continuous barrier of insulation surrounding you. You get the finished OSB surface here, which is nice because now you can apply your ceiling finishes to it, you can apply your wall finishes to it. On the exterior of it, you can apply your siding. When thinking about a conventionally framed house, it's a little bit different than a SIP panel. Oftentimes you've got let's just say your top 2 cords, you've got your bottom cord for your wall framing, and you've got your floor system down below. We're kind of looking at this in elevation or from the side of like a framed wall. So your studs are usually spaced evenly. Oftentimes 16-inch on center is a standard dimension, just because that fits within the rules of a subdivision of a 4x8 sheet of plywood. So we're kind of looking at it from the side here. We often see this in new builds. You'll have electric boxes attached to the side of each one of those studs. And then in the cavity here is where we apply our insulation. So this is, what happens when you build conventionally with a studded system in regular framing members. So whether it's 2x4 walls or 2x6s, usually 2x6s, especially in our climate, you're gonna put some cavity insulation in here, and it can be either batt insulation, or it can be spray foam, or it can be blown in cellulose. It can be a variety of different things. But what's more inefficient about a conventionally framed house is that you get this heat loss in each one of these studs. And this will happen both in the walls and the roof, and you'll see a little bit of that heat loss, especially in the wintertime or when there's frost on the roof. You'll see sometimes the striated lines of the structural members in the roof paneling, for example. So that's like a direct one-on-one example of how you can sort of visually see that heat loss happen. But what's great about structural insulated panels is that that layer of insulation is continuous. You don't have those framing members that are breaking the insulation up and allowing heat to escape kind of quickly through each one of those structural elements. So that gives you a higher level of efficiency using this system, and that's one of the major advantages to it. So if you think about a Yeti mug, it's got an inside surface and it's got an outside surface, and oftentimes you'll get that outside surface engraved or something like that if you want to get really fancy. But within those two layers, you know, sometimes it'll be plastic or usually metal, these two surfaces, and these are just like stamped metal from the factory. And then in between those, they'll put this foam layer. And it's those two layers of material on the inside and outside, plus the foam sandwiched in the middle, that creates a really, really efficient insulation system. Kind of put a little cap on our mug here and just a little handle. And what's nice about that is, you know, if you're me and you've got your coffee in there, you know, it's not going to allow any of that heat to escape out of the system. It's sort of an enclosed space that nothing can escape out of. And that's why Yetis work so well. So we're using this system right now in a couple of different projects that we're working on. One is the lake house up on Lake Ontario. We've got a few unique systems, this being one of them that we're using there. We've got and I'm kind of drawing a section through the building now. This is the basement. These are our foundation panels. This is our unique floor system, which we'll talk about in other videos. But from there up, we transition to this SIP panel system. So on the back wall, we've got a panel, and on the front wall, we have a panel. And the front panels facing the lake are a bit taller, and this allows us to sort of grow the space. So the panels are this allows us to sort of, you know, tilt the panels towards the lake, so you get this really nice sort of exposure towards the lake in these sets of views towards the lake. So this is the sort of basic outline of that building in a cross section using those insulated panels. And you can kind of see there's this nice continuous shell formed by that. Underneath of the panels, we have these beautiful exposed wood beams that run from the front to the back of the building. And what these beams do is they provide the support, extra support for these structural panels. The seams, if you will, of each one of these panels land on our beams that are underneath here. And the beams are nice because they give us that sort of moment of exposed structure where we get to celebrate the beauty of the form and the beauty of the structure itself. But it also provides a little extra support for the structural insulated panels. As you can see in this sketch here, you know, wherever we have these exposed beams that are assisting in helping support the roof panels, embedded within the wall panels are vertical structural members that are actually sandwiched as part of the entire system. Because you don't want the concentrated loads from these elements, these framing, or these beams, if you will, to just land on foam. So underneath those, they have solid conventional framing members that help carry that load all the way to the base of the structure. Another major difference between a SIP panel system and a conventional frame system is the way it's built. So in a conventionally framed system, you're going to bring each individual piece onto the site. You're going to lay them on the deck of the building. You're going to layer them at 16 inches on center, or whatever it is, 24 inches on center. And then you're going to apply the sheeting to each wall. And then you're going to sort of tilt up each wall using manpower from the job, or, you know, if you need a crane or whatever to help you lift that into position. That all equals quite a bit of time to bring each individual member onto the deck, organize it, lay it out, take all the measurements, nail it all together, sheet it, cut out all the window penetrations, all that stuff. You're going to be doing that on the job and then tilting this up into place. Whereas a SIP panel system, you're going to be working with the SIP panel manufacturer ahead of time to give them the specifications, and they'll do a series of shop drawings, which basically how each panel is to be built. You know, the overall dimension of the panel, where the window and door penetrations will be in the panel. It's a fraction of the time spent on the job. And in the world of construction, you know, time equals money. So any ways in which we can kind of increase efficiency, and also, you know, in terms of speed and energy, you know, we're going to take advantage of that.